Yep, that's it. And I'll share that. Can you all see my screen?
Yep.
Yep,
Yeah.
good. Excellent. And it means we can start just at 4 o'clock prompt then.
$20. Well, here am I trying to count them up.
Okay, something I'm realising is I can't admit people at the same time as sharing my screen. So I'm going
I can admit people.
Can you admit people? That's fine. Yeah. If you do that, and then I'll go and share my screen with the presentation. Can other people hear that beeping?
Yeah.
Yeah.
I think it'd be helpful if everybody could mute. I think that would be helpful because there seems to be some sort of feedback. Okay, will we get started?
Right, thanks, Nicola.
Right, okay, I'll hand over to you, Douglas. Thanks everyone for being here. I'll hand over to
thanks
Douglas.
a lot. First of all, welcome everybody, and big thanks to all who are giving up their time to join us. And McDonald. Okay. We hope that Fran will quieten down. Yeah, a big thanks to everyone. We really appreciate the demands on your time, and it's great so many are able and have taken your time to join us. Begin with the introductions. Nice for me to recognise a number of very familiar names and in fact see a number of very familiar faces. For those that don't know me, Douglas Buchanan's my name. And for more years than I care to remember, I worked at a place that I affectionately called Furry Mouse, the Murray House School of Education. And during that time, I did a wee bit of this and that as well in the chemistry education scene in Scotland. Colin, do you want to say a few words about yourself?
Yep, I'm Colin Gill. I'm ITE lecturer at Edinburgh Napier University. Before that, I was a chemistry teacher and then a faculty head of science in West Lothian. If you're wondering, we're sitting here together, in case you think it's some kind of split screen thing, Douglas is in my box room with me. He was asking me questions about the technology, and it just became easier to invite him round. so we are sitting here in my flat in Edinburgh. But yeah, Douglas was heavily involved in providing advice and support when Edinburgh Napier went into teacher education, and he has been helping out there a bit recently as I was off on paternity leave for a bit. So you may hear some noise in the background as well because of that.
Right, thanks, Colin. Paul, I learned today that you got a High Achievement Award. Yeah, tell us a wee bit about yourself then.
Hello there, my name is Paul Murray. I am a chemistry teacher at Kirkcaldy High School right here in the Kingdom of Fife. Before I was a teacher, I worked at the University of Edinburgh as a kind of junior lecturer and researcher and science showman. I've been here at KHS for nearly a decade now, nearly 10 years, and for all its faults and foibles and bizarreness, I absolutely adore it. As Douglas is saying, he was admiring my tie before everyone came on the call. I have a Kirkcaldy High School Achievers tie as a result of getting a couple of awards for the school in 2018 and again just in 2020. So yeah, very proud of that.
Thanks, Paul. And we're not joined with Laura at the moment. I think Nicola
Yes.
here from the RSC.
Yes, hi there, I'm Nicola Jordan. I a former chemistry teacher, and I've been working for the Royal Society of Chemistry as a programme manager here in Scotland for roughly 5 years, and I'm based up in Forres, so I'll hand on. Thank you, look forward to this.
Sounds like a dentist surgery. Hey, just before we go back, well, I'll blether to this slide. What I wanted to do to begin with is say a wee bit about the context for this meeting. At the UK national level, the RSC has been quite heavily involved in the chemistry CPD arena, and a number of us in Scotland have contributed to the various online sessions. And while we recognise the value and the evaluations have been fairly positive, those from Scotland have felt that they could be improved if they were to give them a clearer and closer connection with both the curriculum in Scotland and the needs of Scottish chemistry teachers. As a result, a small group got together in spring of this year, and we decided to try and build on the RSC material to try and produce something specifically for Scotland, to try and produce 3 workshops that we could put online in the autumn term. For one reason or another, we were going to start with chemistry calculations, but we never quite get finished with that one. But rather than not go ahead, we decided we'd go back to a material that we already were familiar with, and that's why it's active learning today. We hope that there will be resources that everyone will be able to take away and use almost immediately back in school. Napier University, I've been in and around now for the past 3 years, and it's fair to say they've got an interest in joining the CPD arena, and as a result, Napier and the RSC are exploring the possibility of forming a partnership to provide support, not just in the area of online CPD, but a whole variety of ways. But we're really just taking tentative steps in that direction at the moment. We're aware that CERC are in existence, and we're not trying to think about competition for CERC, much more. We very much hope that we can complement the work that CERC are doing. But as I say, at the moment, the priority is simply 3 online sessions between now and Christmas, and this is the first one. I've got to say that I'm particularly apprehensive about this afternoon's session. First of all, I find it very hard talking to a computer screen. I'm much, much happier when I can see the face of the people that I'm upsetting, and I might even see some folks smiling. Some folk might even agreeing with what I'm saying. So this business about talking to a computer screen is pretty strange to me, and I'll simply do the best I can. The second reason, as many will know, certainly those that know me, is that my IT skills are pretty low in the learning curve. And I'm just so grateful to be sitting next to Colin today, because we did have a few teething problems in the setting up, and Colin and Nicola together have managed to ensure that not only can the presenters see the slides, but the participants can see the slides as well. So thanks a lot to all those who contributed in actually putting this together in terms of the screen. And the third reason for being particularly apprehensive is that this session is about active learning. And if I was doing this face-to-face, what I would be trying to do is model the activities to give folk who are participating an idea of what the kids actually go through in school. But obviously, that's much, much more difficult with an online session. And so I realise the limitations, and I apologise in advance that We're just not able to have the kind of active learning that we would like in this workshop because it is online. The next slide, Nicola, I think is about housekeeping. Do you want to add anything?
It is, no, I've nothing really to add. Just please mute yourself. The reason for that is to avoid the background noise. If you've got any questions, type them into the chat and Colin and I will be able to have a look at them. It might be we missed them at the time, but we'll come back to them if we can. But please feel free to ask questions there. Okay.
Right, thanks, Nicola. If you could go on to the learning outcomes. I'm a great believer in sharing the learning outcomes for those involved in the learning, and here are the learning outcomes for today's workshop. That's then written in one way. I always find it hard to resist the temptation to show the same learning outcomes written a different way. And we can think about the difference between the two. That's one form. And if we go back to the slide before, that's a second form. Now, I wonder what's the difference between the way the learning outcomes are written in the two slides? We'll not ask folk to write anything in chat. The key point is that the second set are written in the form of questions. And I've often asked participants, teachers, to go back to the classroom and carry out a wee experiment. Share the outcomes in the form of questions, share the outcomes in the form of enable type statements. And when I followed it up and asked teachers about what the kids prefer, then it's almost always that they prefer one more than the other. And I wonder which one that is. It is the learning outcomes shared as questions. So if you haven't tried that, then I suggest it's something that you think about when you have the time to get round it, I suppose. Okay, going on to the next slide. We're thinking about what we really mean by active learning. You talk to primary teachers about active learning and they immediately think about taking the kids outside and they run about the playground doing this and that. Talk to some secondary teachers and they immediately active learning. Oh, that's when the kids get out their seat. That's when they do practical work. That's what active learning is all about. But the key point for us, it's not about that kind of action. It's about brains on rather than hands on. And we're thinking of the sequence, think, discuss, and learn. And the key word in the middle is discuss. Thanks, that's fine, Nicola. Move on, yeah. Discuss. And I can think back to the early days of my teaching, and I went to a meeting that was taken by the advisor of English. It was about so long ago, I can't remember the exact date, but it was about 1979. And at this point, the Bullock report had been written, and it really highlighted the role of language in learning. And Jack O'Neill made the point very, very strongly of the four modes of language, listening, reading, talking, and writing. The two that are most associated with learning are writing and talking, especially talking. And if we think about it, you know, I could ask you to read about what's going on in Afghanistan at this time. I could actually ask you to listen to me talking about it. And I suppose your brain would be on in one way. But if I asked you to talk to the presenters about what was going on in Afghanistan, then your brain would have to be switched on in a quite different way. And your brain would be asking questions as you were talking that would sometimes be answered when talking. At other times, you would be thinking, well, that really is not all that clear, and I'm going to, at some point in the future, think about it in a bit more detail. The key point is that talking is really, really powerful in learning. And I suppose that's really at the heart of active learning. if we're looking for further evidence, we can look at the work of Shirley Clarke. She's written a number of great books on formative assessment, but in one of them, she makes it absolutely clear that one of the cornerstones of formative assessment is active learning. Active learning, formative assessment. And we can have evidence from research about the benefits of formative assessment. If we go to the work of, the next slide, the work of Paul Black and Dylan Wiliam, very well known for Assessment is for Learning, and one of the most influential books inside that. Just it's a small handbook, but with so many pearls of wisdom when it comes to effective teaching and learning inside the black box. They carried out a study, and they had departments involved in CPD, and then they followed the teachers in the departments back into school. And then they looked at the results of the national examinations. And what they found is that where whole departments immersed themselves in assessment is for learning, formative assessment, or what we could maybe call active learning, then the benefit was at least half a grade at GCSE for a department. They also found that the low ability benefit most, and I suppose that we might think that that's rather obvious, and that there was an accumulative effect if it was introduced on a whole school basis. My personal view, no real evidence, is that the high ability benefit just as much, but our exams are not really clever enough in order to pick up the added benefit. But the black box folk, for me and many others, provide really powerful evidence. Just before we go on to this next slide, what's interesting is that although the black box found that there was an improvement in performance in national qualifications, they also found that a significant number of teachers did not complete the course. If you're really involved in active learning, one has to recognize that it takes time. And if you think about, how could not completing the course result in improved performance? I suppose the argument goes something like, if you complete 100% of the course and you get 40%, then that's a mark of 40%. If you complete 90% of the course and get 60% of that, then 60% of 90% is a better mark. And I'm not suggesting for a minute that you set out not to complete the course, but if you are heavily involved in active learning, then you have got to expect that it does take longer to get through the work. But perhaps it's not a race to get through the work, it's the quality of the learning that really matters. And keeping kids with you as you go through a course, rather than just getting through the course, is something that I think we all have to keep in consideration. Right, I'm going to stop blathering for a minute, and Colin's going to say a few words.
Yeah, I just want to kind of talk over this slide, which gives a kind of explanation of why active learning strategies might be of benefit to pupils. The diagram here is just a kind of simplified diagram showing the cognitive scientist Dan Willingham's kind of idea of how learning happens, right? It's a very simplified diagram, but basically the first part of it is almost like what we're not going to talk about today, because that's a whole different world, is that our pupils have attention to something in their environment. We are hoping that what they've got their attention on is what we want them to have their attention on, but as I said, that's a whole other ballgame. But when we take attention to something, it goes into our working memory, right? And from our working memory, we can either learn it and it passes into our long-term memory, or it can be completely forgotten, right? We obviously want it to be learned and go into long-term memory, right? And the research has shown that by engaging with the material, using these active learning strategies, by linking it to prior knowledge, by linking it to how it might make us feel, or how we might kind of how we might take on board that new information and link it to things that we've learned previously, that helps to put it into our long-term memory. Okay, and discussing it with other pupils is going to help with that as well. Okay, and Dan Willingham's famous quote is that memory is the residue of thought. If we want things to pass into our memory, we have to be thinking about them and using that information in our working memory. Okay, and that's what these active learning strategies help with. Back to you, Douglas.
Right, thanks a lot. What we're going to do this afternoon is look at a number of active learning activities. Many of these I've picked up from students over the years, and I'm very, very grateful for their contributions to what I'm going to talk about today. I'm terribly aware that a number of you will very likely have seen some of the slides already. If that's the case, I don't mind if you want to watch telly at the same time, make a cup of coffee, feel free to walk about. I hope that perhaps going through them again, it will refresh everyone's minds about the value of active learning, and maybe even there's something new for everyone. We're going to talk through the left-hand side, and then we'll get a wee break from myself, and we'll get the voice of the real teacher, Paul Murray. And then we'll finish off by going through the right-hand side. Okay, and the next slide, Nicola. Yeah, something to keep in mind. I've used this slide and the next one often, using ideas in your school. If you're going to do something that you haven't done before, you're really doing a wee experiment. And of course, we all know that experiments involve risk. So when we do something different with a class, what we want to do is try and keep the risk as low as possible. And different teachers have done this in different ways. Some teachers have introduced active learning in the early years with particular classes. In the early years, no national exams to worry about, don't get through the course, not too much to worry about. And they've taken the decision to introduce more active learning in the first and second year. Some schools have taken what I thought is quite a big risk. You know, they've actually decided to go with the higher class. And when I've asked them about, you know, why are you beginning with a higher class, such a risk, difficulties getting through the course, they felt that the kids possibly were better prepared, you know, to deal with, you know, some of the freedom that goes with active learning, to take responsibility for some of the freedom that has to be in place for active learning to take place. So the first step, if you're introducing something new, is to think about carrying out an experiment. And of course, if the experiment works, the next step is to try it again. And if you try it again, if you expand in the experiment, it continues to work, then what I think you will want to do is actually embed it in your teaching, so that you have active learning, a greater degree of active learning in more of your classes. So keep in mind the sequence: experiment, expand, embed, and also remember on the next slide, how do you eat an elephant? Now, if you've been asked that question, you all know the answer. Those that know the answer will know that the answer is
one bite at a time.
One bite at a time. And if that is the next second part of this slide, we do it in small bits. So it's terribly important that if you feel that there are a number of active learning activities that you're looking at and you would quite like to try them out, you resist the temptation to try them out all at once. Much better to take one class and carry out the experiment. If you find that it works with that one class, try and do something similar with other classes. And then you might want to embed it in your teaching. Having done that with one activity, the next step is perhaps to try the same with another activity. I mean, I can remember going to meetings and come back full of enthusiasm, and I wanted to do this and I wanted to do that. But when I was back at the ranch, I found that it was pretty difficult to find the time to do anything. And I think we've really got to be realistic. It's much better to take one thing and do it well than try and do 5 things and get frustrated, because you can't really measure in any meaningful way whether you're making any progress. Trying to do one thing and do it well. If you're into the business of self-evaluation, which I hope you all are, then it's much easier to make judgments about the effectiveness of what you're trying to do. Okay, thanks, Nicola. Next slide. Yeah, we're now looking at a range of active learning activities. Practical investigations. It's I can't really get my mind around the difficulties in these COVID times. You know, can kids work together? Can kids talk? If they can't talk, then we're missing out on what really, really matters. The kind of language that leads to learning. And it's very important that we try and help the kids to be aware that it's the processes that are really important. I mean, I can remember the kids at the end of experiment, hey, sir, have I got the right answer? You know, and it's really not all about the right answer. It's about, you know, how I get on in my planning, the way I record my results, the limitations of my method. And it is important that we make kids completely aware that the processes are important and they can talk through the different elements of a practical investigation when they carry it out. And the next slide, again, which I've used a lot, it's important that we see failure, not getting the right answer, as a dropping off point in the way to success. So many, as I said earlier, they're just fixed in finding the right answer. If they don't get the right answer, they think, oh, that's no good, I can't learn anything. But there are huge opportunities for learning when we get answers that are maybe different from others in the class, and trying to persuade the kids that failure should be seen as a dropping off point in the way to success. It's not all about finding the right answer. You know, we often talk about, you know, problem solving. Is it something that some folk are able to do and others are not? And my own view is that we can build the confidence of those who may not be very good at problem solving to begin with, just encouraging them to try and keep trying. And we can do that by persuading them that there is much to be learned from not getting the right answer, very often more. And it's not all about trying to find the right answer. The best answer. There are a number of teachers I know that rather than give the question to the students, they give a number of answers. And the task is to actually come up with what is the best answer. And in some cases, the best answer is a distillation of the partially correct answers. And it'd be interesting, you know, how many, in fact, use this kind of technique. You don't really have to worry about making them up yourself. If you just look at the answers that kids give you to the questions and you take a note of them, and you do this on a regular basis, it's not too long before you have a bank of incorrect or partially correct answers. And this is just one set of answers from looking at what happens to the pH of an acid solution when water is added. Yeah, best answer: when a candle burns. For better or worse, those that know me, that at one point I used to have to spend a bit of time away from home, and the choice of sitting in a hotel room watching the television or reading detective novels, or I could go to a place that they call a pub. And it's great when you're in a pub. Everyone knows more about education than you do. Everyone's been to school, so they've all got the answers to all the issues when it comes to education. And I like to engage with the folk in the pub, and I tended to engage about two issues. One of them, what do we mean by learning? And I'm not going to go into that just now, but I would ask them about, what do you really understand? And I get wonderful answers from folk in pubs about learning. But if it was getting near dark and they come round and they light the candles, I would be asking folk about what happens when a candle burns. They would look at me as if it was Christmas crackers, but I said, look, I'm actually quite serious. I'd like to talk about this. I'm dead interested in chemistry. I would like you to be as interested as I am. And here are some of the things that folk have told me about what happens when a candle burns. You could think about trying it out with folk at home if you're interested. If you're looking for a wee interest catcher at the start of a chemistry course, it's something you could give the kids and ask them about what really happens when a candle burns. What would be the best answer? And if we had a wee bit more time, I would like to have prepared a wee video that shows you. I mean, you can really demonstrate to the kids without any difficulty at all if you're careful. You light a candle and you have a splint relatively close by, and you're going to blow out the candle flame without blowing out the splint. If you're able to do that, you can then move the burnt splint across to the candle, and you can see the flame jumping from the splint to relight the wick. As I say, you need to practice it before the class because it's pretty easy to blow out the taper as well as the candle flame. But it's something you can develop, and it's not too difficult to do once you're used to it. Next slide. Yeah, use of incorrect answers. And once again, you don't have to make these up. You don't have to make up, for better or worse. When we give kids questions, sometimes, believe it or not, they produce incorrect answers. This is one I tend to use with teachers. It's not from kids. If we had more time, and I would say I would be trying to make the learning more active, to give folk an idea what it's like working with an incorrect answer and trying to unpack what's the truth and what's completely incorrect. And having worked with quite a number of teachers, giving them this example, it's amazing the number of folk who are actually not completely sure about carbon dioxide in the atmosphere and the greenhouse effect. And I'm talking about folk, maybe not those with chemistry degrees, but those without being critical of our colleagues' physics and biology degrees. This business about the greenhouse effect. Yeah, it's something of interest. The next set, if I remember from the slides correctly, yeah, here's incorrect answers. Here's what kids have told me in the past. Apologies if I'm going through it a wee bit too quickly. As I say, it's easier when you can actually see the audience and you get an idea of whether they're still reading or whether they're all now fiddling and drawing whatever they draw at the top of the page. Nicola, I think you said it is being recorded. The slides will be made available, is that?
Yes, yeah, we will make the slides available as well as the recording.
So if we're moving a wee bit too quickly, apologies, and you will be able to look at in your own time. Brainstorming, what do you know about? You could be starting a new topic, and it's always good to know just what the kids are bringing. Acids and alkalis is a particular one, you know, it's maybe second year. Some kids know not quite as much as the teacher, but a great deal about acids and alkalis. They know about the pH scale. Someone at home has got a pH soil testing kit, and they know about the colours, they know about the numbers. And it's great to know those in the class that are going to help you when it comes to supporting those in the class that need support. So we could be doing this at the beginning of a topic, but we could also be doing it at the end, because it gives us an idea about what we may need to sort of re-emphasize at the end of a particular topic. And these are just some of the topics that we can use for brainstorming. I used to give them a piece of foolscap paper, and they would just scribble away on the foolscap paper. And linked to this is the next one, walk about, talk about. This is sometimes called the carousel. And at the end of a topic, you could break it down into subtopics, and class arranged in groups, each group given a particular colour of felty tip pen, and they go round and they each start with a different one. After so many minutes, they move on to the next one. You might be decreasing the number of the minutes as they move round. And then they eventually end up back with the one that they started with. And if they all have a separate colour pen, you could immediately identify who said what. And the kids are often able to question other groups, and they know which group to question because of the colour of the pen. And I'm sure many of you will make use of this activity. And if you do it and it works, keep doing it. If you haven't tried it, it's something to think about. Okay, similarities and differences. And the next one is just two others that are something in common, something different. Yeah, and I think this is the last one before we go on to Paul. Similarities and different, yeah. Think about this. How do the kids feel if you give them a test? In days gone by before COVID, you would be saying now, make sure no one can see your answer, separate from your pals. No talking, please. This is a test. Silence. Work through it. In 5 minutes, I'm going to get someone to come out to the front and go over the answers, so make sure that you do well. How do the kids feel about that? You could take that test and you could give it to the kids in a different form in the next slide. What you can do is give it to the kids in the form of cards. And what they do is they'll give it two headings, and they take the cards and they can move the cards about. The great thing is that if they change their mind in a test, there's evidence, you know, they've got a rubber or something in ink is being scored through. Here, they can start off by thinking that one, maybe not in this case, but they can change their mind. Molten sulfur, I think it conducts electricity. A wee bit of chat in the group. Does it conduct electricity? Is it going to conduct electricity? Is it a metal? Is it a non-metal? Oh, where are we going to put it? they get the chance to move it about, and there's absolutely no evidence of the incorrect thinking. And of course, they're doing this as a group. They can talk. And the great thing is when you go over it, whoever you ask to talk is representing the group. If the answer they give to the question is right, they take all the credit of the group. If the answer they give is wrong, well, they say it was not really my idea. It was someone else's group that wanted me to say that. I think most folk would agree that, yeah, okay. No, can we just go back just before we move on, Nicola? Yeah. Most folk would agree that using a card sort, is much more friendly for the kids, and it's much more likely to lead to learning. In a test, all you really find out what the kids know already, and they don't really move on as a result of the test. I think it's a bit naive to say that just because I go over it at the front of the class as a teacher, everyone will now know the right answer. If only teaching was as easy as that. There's a bit more to it. And the bit more to it very often involves the need to have discussion to break down misconceptions. When I gave it to the kids in the long distant past, there was one there that the kids got wrong much more often than all the rest. I wonder which one it was. Paul, would you like to guess?
I'm going to go for the Mercury one.
That, I think, would be second.
That's the one. When I do this particular one, that's the one they get wrong a lot here.
I think it might be a lot of the way the teacher that I taught it, you know. Kids' misconceptions are very often down to the way the teacher teaches it. For me, the one that if they were going to get one wrong, more often than not, it was the molten iron. I clearly didn't make it clear that, sorry, there's two there, molten iron and molten lead. If it would be two. Obviously, when I was in the early days of my teaching, I realised the problem as I went on, that I didn't make clear when I was showing that metals conduct and non-metals don't. The metals, even though I showed them liquid mercury, and liquid mercury still conducts as a liquid. And I would say if they got molten iron or molten lead incorrect, it's, you know, why do you say it's incorrect? It's always interesting to ask them why. And they would say, molten iron, it doesn't conduct as a melt. And I said, what about liquid metal? That's a liquid, sir. That's not a melt. It was quite interesting. And always interesting that when you're going over something to unpack I wonder why, when you get things wrong. And the last slide that I'm going to talk to before we go on to Paul, well, one more. I think what I'm trying to demonstrate here is that good testing devices are good teaching devices, and a good test can be a learning as well as testing experience. Brenda Kirk and Stuart Naylor are the authors behind Concept Cartoons, for those that don't know. Sadly, Brenda Kirk is no longer alive. But they've been very, very influential in terms of concept cartoons. And I think that's something that made a big impression on me. Good testing advices. Rather than giving them tests, we could change the content and make it into a good teaching device. And the last one...
Sorry, me now, I think.
Oh, yes, it's back to, sorry.
Yeah, I just want to talk a bit more about using kind of tests as a teaching device. You know, there's a lot more coming out now about retrieval practice, and a lot more teachers are hearing about retrieval practice. And just this idea that a good test, right, it's a very good learning device and not just a testing device. You know, now retrieval practice is all about using tests or some sort of assessment, but making it very, very low stakes. Okay, we can go into the next couple of bullet points if you want, Nicola. You know, just making it very, very low stakes, and the deal being retrieving things from our long-term memory helps to strengthen those memories. So the more we get pupils retrieving things, instead of just putting information in and knowledge into their heads, of getting them to get it back out again, and that's what strengthens it. Okay, so you can give them short tests or any other kind of formative assessment strategy, but not caring and making it quite clear to the pupils, not caring about how many they get right or wrong. It's all about learning. What they get right or wrong gives good feedback to us as a teacher, right, about what we need to maybe reteach or what the pupil needs a bit of help with. How it fits back in, here's just another kind of diagram which shows this kind of model of the memory, and you can see the retrieval from the long-term memory to the working memory. It's that retrieval, bringing things from our long-term memory back into our working memory, which stops it being forgotten from long-term memory. If we don't retrieve things, we'll forget them. You know, for example, if I'm in a hotel, the length of time I'm in that hotel, I will remember what room number I'm in, okay, because I'm thinking about it and retrieving it from my memory all the time. Ask me what the room number was 2 or 3 days after I've left that hotel, I won't be able to tell you what room number I was in, okay, because I'm no longer retrieving it, I've forgotten it. So we can use tests as good learning devices, right? I hate to plug anything, but that guy's books are quite good for them as well. You know, the wee A5 books, just full of questions, but great, not using them as testing devices, using them as learning devices. Okay, so we can use tests, we can get pupils just to self-check their answers, so it's not adding any workload to us as teachers. Other things we can do, we can get pupils to draw mind maps so that they're thinking about how concepts link together and bringing them back into mind. Or things I do because I'm a lecturer now, and you can't really do a lot of these activities as a lecturer, and lectures are just not very active at all, is that I'll stop halfway through the lecture and get the students to do a brain dump. I'll be like, right, you've got 3 minutes, write down everything that you've learned so far in this lecture, so they're recalling stuff. It's not just stuff that's going into their memory, but they're actually recalling it again, and that's strengthening those memories. Okay. And you can space that and do it out of different lengths of time. I've put a link there that you'll get in the slides, the Learning Scientist website, which has got loads of great strategies for how to do retrieval practice, spacing it out. If you want to read more about it, Kate Jones has got a couple of great books on it as well. I think they are imaginatively titled Retrieval Practice and Retrieval Practice 2. So they're definitely well worth a read. But I'll pass back to, I don't know who I'm passing back to now, actually.
Well, we can just quickly go through these slides. You're going to be able to look at in your own time. And here's just like true, false. True, false, if we add the can't be sure, then it takes it to a different level. The can't be sure is not, I don't know the answer. I think it's this, but I'm not certain. If we take the first one, all compounds containing carbon, hydrogen and carbon can be classified as a hydrocarbon. Is that true or false? That's false, is it?
That's false.
That's false. Is there one that can't be sure? A compound that burns to be just the last one, maybe.
False, yeah.
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 Yeah,
all compound containing hydrogen and carbon can be classified as a hydrocarbon. No.
Yeah.
Containing only hydrogen and carbon can be classified as hydrocarbons. But in some other compounds that may contain hydrogen and carbon but not classified as a hydrocarbon.
Good. Yeah. So that's an example. Okay. Next one. Different. You could put that in the form of cards, but here these are all what we call card sorts, and that's another example. Okay, next one is another example again. I got this from a lady, a fantastic chemistry teacher, Trish Nicol, who taught at Pennycook High. And these were taken from, she gave me them as just a different form of cards. Yeah. And Tarsia. Tarsia, Paul, you could say a bit about Tarsia and then a wee bit about the next few slides.
Yes, so Tarsia puzzles, if you're not familiar with them, if you do a Google search for Hermetic Tarsia, you'll find a little program that you can use to make them. It's originally designed for maths, so you can do write in what's called maths ML, which actually can sometimes be quite useful for a scientist, because particularly chemistry, doing subscripts and superscripts. But they're just a sort of another way of doing matching. And as it so happens, I've got one sitting right here that I did today. This is my moles dozen Tarsia, trying to get across to the kids this concept that the mole is just another name for a number. So this has got things like a baker's dozen, and it's got, you know, a dozen and some weird ones, a gross and a score and stuff like that. And it's got a mole on it, and they have to match them all up, and it makes a big triangle like you can see here. It's also got things like half a baker's dozen and 0.8 of a mole and a couple of others you have to kind of calculate it as well. So that's I really like them. They're really, really good. And I've got loads and loads of them. And in fact, what I've done is I have zipped up all of my Tarsia puzzles into a zip file, and I'll give them to Nicola, who can put them somewhere to share, and you're welcome to them. There's some for first and second year, some for national 4 and 5, and some for higher as well. A bit of a mix there. So feel free to help yourself to those.
Thanks for that. It's really useful. We can share them. Yeah.
No problem at
Move
all.
on.
Do you want me to talk now, Douglas? Can I actually share from here, Nicola? Would that be okay?
Yeah.
Can I give that a wee go?
Yeah.
I've got stuff sitting on the board just now, so we'll give it a go.
Okay.
Is that work okay?
I can see yours. Can everyone else see your slide?
Can everyone see that okay?
No, there's people. Oh, they can now.
Oh, yeah,
okay.
that's good.
Yep,
That's
I can
fine.
see them.
So just to kind of expand on a couple of things that Douglas said, but also to talk about a couple of other things as well. First of all, the aims. Oh, Jeff. First of all, to apologise that I have to go at 5 o'clock sharp because it's parents' night here at Kirkcaldy High School and it's virtual, so that's going to be starting very soon. And I've got another computer sitting over here, right? So yeah. Just to expand on a few things that Douglas said. First of all, the aims as questions, but this is actually something that I've picked up and I do all the time. I pitch all of my aims, my learning outcomes, if you like, as questions. And as a scientist, one of the reasons that I do that, and one of the reasons I think it works particularly well, is because it fits into the scientific structure really nicely. Because the kids are often quite confused about this business of what a conclusion actually is. Like, how do you write a conclusion? What does that even mean? But if your aim is written as a question, then your conclusion becomes to answer the aim, to answer that question. And that sort of circular format works quite nicely and works quite well for plenaries at the end of lessons as well, because your plenary then becomes, okay, this was the aim, answer the aim. And that's what you're looking for at the end of the lesson. So that struck me as Douglas was talking about aims as questions. And also to do with plenaries, this also struck me as Douglas was talking. This is a very common plenary that I use, is the 3 pieces of advice plenary. So if we've done, say, a calculation, and this is one that we're doing with the 4th years at the moment, the CM delta T calculation, classic stuff. Chemistry teachers have been doing this for many years. This is one of my favourite plenaries particularly for that sort of technical kind of stuff, is to write down 3 pieces of advice for people doing the calculation that you've just done. And you'll get stuff like, oh, you need to remember to usually you need to remember to divide the volume by 1,000, or remember it's 4.18 usually, but it might not always be 4.18, stuff like that. The kids actually come up with really good stuff, and it's quite a different way, rather than just say, oh, do another one just to prove that you can do it. Actually gets them thinking more about the calculation. So to me, it's more of the sort of active learning ideal there. Just to kind of talk about a couple of other active learning bits and pieces that I use. I like talking of questions and questions that you're not looking for a right answer. I like a question that doesn't have a right answer at all. And this is a very good example of one that I made. And I've given this question to all sorts of audiences. I've given this question to chemistry audiences. I've given this question to non-chemistry audiences. And it's really interesting the extent to which the non-chemistry audiences in particular will panic looking at this question. And I will generally say to them, there is no wrong answer to this question. Like, whatever answer you come up with and whatever justification you give will, by definition, be the right answer. And sometimes you'll get a clever clog saying, okay, I think it's krypton because that's the only noble gas, which I think it is as far as I remember. Or you'll get somebody saying, oh, I'm going to go for iron because it's the only one I've heard of. Great answer. I'm going to go for cesium. It's the only one that starts with a C. You know, however people choose to answer a question like this is totally up to them. And it really gets folk thinking in all sorts of different ways. And I really, really like that. But again, if you're going to ask a question like that, particularly if it looks like it's a chemistry question, you have to caveat it quite carefully with the bit there is generally no wrong answer. And people often don't believe me. They think that I've selected a right answer. There secretly is a right answer in there. It's not. I literally covered my eyes and went to the periodic table like that and just put the ones in that my finger hit. There is actually generally no right answer to this question. I generally just picked a bunch completely at random to put on this particular question. Something I've been playing with recently, as a result of speaking to my 4-year-old niece, is a concept of play-based learning, which kind of, again, to me fits in quite nicely with the active learning, not because it's actually up doing stuff, but because of the way I'm sort of trying to get the kids to think about this. So my 4-year-old niece has just started at Cookin Primary School in Pennycook. And she was telling me, as her big sister was, who's 8, who went through the same school, that they have no tables and chairs in their classroom. They have a carpet and they sit on the carpet and they do stuff on the carpet. and they have little corners of the room where they go and do things in the corner of the room. And the teacher kind of goes around, and maybe they're playing with, I don't know, they're playing in the kind of fake kitchen, and the teacher's going, okay, let's count the P's, 1P, 2P, you know, and it's a play-based learning ethos. And I thought this was really interesting. So, okay, I like that. That's kind of interesting. I wonder if I could apply that in my classroom. And okay, I don't have a fake kitchen where you can count the P's, but could I do something similar? And I was doing, again, a classic thing, ray boxes, you know, lights, prisms, the lot. And I was kind of noticing the kids actually just love to play with it. They want to get out and play with it. So I actually kind of pitched it to them. Okay, you're going to get the opportunity to play with this. And exactly what you do with this, I really don't mind. But I'm going to give you a couple of things that you need to do. So one of the things you do need to do is you've got two different lenses. There's a fat one and a sort of curvy one. You need to make sure that you put the ray beams through those lenses and write in your books what happens. But apart from that, you've got 20 minutes, however long, you can do with these what you like. And even with some kind of chemistry stuff, I think we can do that. If you think about it, for the vast majority of chemicals we use, there's very little safety implications whatsoever. So if the kids choose to mix that chemical with that chemical, it really doesn't matter, because actually, for the most part, it's probably going to do nothing. And so I did this with alcohols and carboxylic acids a couple of weeks back. And I said to the kids, okay, you're going to learn, we're learning about alcohols and carboxylic acids. What would you like to know about alcohols and carboxylic acids? Or what happens if you add the hydrochloric acid to it? I don't know. Give that a go, see what happens. And again, there's not a particular safety implication there. It's not going to blow up in anybody's face. It's going to be okay. So they can do these kind of things. And so again, I pitched it at them saying, okay, you can actually do pretty much what you want with these things. You know, there's okay, a lot of they get in your hands, wash them off, that kind of stuff, fine. But actually within the main, you can do what you like. Here's some marble chips. I'm going to tell you to react them with marble chips and see what happens. I'm going to tell you to do a pH test on these with the universal indicator. But apart from that, you can kind of do what you like. If you want to add this one to that one, go ahead. That's no problem to me. And so, yeah, it actually, again, it worked quite well as a sort of play-based learning and getting the kids the opportunity to kind of actually do the things that we're generally wanted to do. What happens if you mix it with this? What happens, you know, all that kind of stuff? Well, actually, go ahead, find out. Another one is sort of not necessarily wrong, but this kind of pertains a bit to Douglas and his wrong answers, although these are not necessarily wrong, but they can be a lot better. And so this is a bunch of statements and very common statements that I'll see from kids. And how can you make these statements into chemistry answers? At the moment, they're not really chemistry answers, and a couple of them actually don't say anything at all. How can you turn them into chemistry answers? And I've actually recently added the bit at the top that says using the words particles and collisions, because the kids were still really not getting the sort of point of this. They were not getting into the chemistry of it. So I was going to give them a wee bit more scaffolding. It's okay, what I'm looking for here, take these answers, add these words, take it, thicken a cocktail shaker, and give me something that's a bit more chemistry. And they were starting to get there with it. So that's one that I've kind of enjoyed using. I think the kids have liked it as well. Douglas has talked a lot about card sorts. This is a kind of quite unusual card sort that I came up with. The kids were doing we do loads of mole calculations, and the kids were struggling to figure out what particular calculation should look like. And okay, is this a mole calculation? Is this a gram formula mass? Am I calculating the mass of 1 mole? Am I calculating the mass of several moles? What am I doing here? And actually, they were struggling to sort of visualize on paper what a particular calculation should look like. So I came up with this. It's a bunch of questions and match them to the working out. So if you're doing a gram formula mass, we would probably expect to see the thing with the drop down arrows. If we're doing a chemical formula, we'd probably expect to see things being swapped from one side to another, stuff like that. So trying to get that visual picture in their heads of what a particular calculation should actually look like. And the final one, again, I think this is probably one that everybody used, but I just wanted to chuck it in there. Again, the sort of idea of looking at wrong answers. A great way to do that is to pick up the materials on the Understanding Standards website of the SQA. Of course, the SQA is going to change. Who knows what that's going to look like, but I'll park that for the moment. To pick that up. And if you do that, you can actually get the kids to start marking some answers. You can do the sort of Understanding Standards thing. You know, if it's an open question, do you think it's a 3, a 2, 1, or a 0? Hold up your boards. All that kind of stuff. So those are some of the techniques that I use. A wee comment on Douglas's card sorts. I really, really like the card sort thing. Quite a common thing for me to do with a card sort is at the end of it, I'm still one of these people who has a random selector. In the classroom, I'll do a random selection. Okay, tell me about a couple of them that you found tricky. I'm not interested in your right answers. If you manage to sort them really quickly, I actually don't care about that. That's not what I'm interested in. I want the ones that caused you to fight with your mate and nearly bring it to fisticuffs over whether it goes in the true or false column. That's the one I want to know about. So take those ones, and when you get selected, those are the ones I want you to talk about. Were the Parzia puzzles, were there any that you really struggled to match? Were there any that you couldn't match? Actually, I'm interested in the ones that you couldn't get right. I'm interested in the ones you got wrong. So let's talk about those. So yeah, again, in terms of sort of how it fits in the classroom, that little structure works very well for me. The final thing I'm going to say before I have to go to my parents' night is a wee health warning. One of the things I've noticed in my own teaching is I sometimes jump to the active learning task a little bit too quickly because I quite enjoy it and I quite think it's the best fun bit of the lesson. And sometimes I've actually come run aground because actually I've not given the kids enough background to access the active learning task. So I've had that happen to me. So that's a wee warning. That's actually something that I'm working on in my own teaching at the moment, is making sure that I've given the kids enough background to actually access the task. And I'm going, brilliant, let's get the cards out. Here's your cards, folks. And they're just all looking at me going, we don't get what you're talking about here, Dr. Murray. So that's problem number one. And the other thing to watch out for, again, from experience, is active learning tasks that actually cloud the issue. That actually what you've maybe done is you've taken something quite simple and actually made it more complex by making it into something that's got more parts to it than it actually needs to have. And you've maybe thrown the kids off the scent by doing that. So sometimes the active learning task is maybe not the thing to be doing as quickly as you might think. And that's me, guys, and I'm going to have to go at my parents' night, so I'll see you again another time. Thanks you, folks.
Thanks so much for coming, Paul. That's brilliant. Thank
No
you.
problem at all.
Okay, and Nicola, I think what we'll do is we'll try and quiz through the rest of the slides. Folk are going to be able to see them at their leisure when they're sent out. And the plan was that we would have an hour. We're going to maybe just go over that, an hour of more structured learning, and then some time for flexible learning. Anyone wants to chat at all? Okay, so if we could just zip through the remainder of the slides, okay?
Okay, that's fine. Just give me 1 second and I'll get it back on.
If anyone has to go, our apologies for going on a little longer than we maybe intended to.
No, right, I've gone back anyway. Hang on. Just
Oh,
tell me when to stop. Tell me when to stop.
Just keep going. Yeah.
Loads to go.
Yeah, next.
Oh.
That was my rubbish.
No worries. Yeah. Next one. Yeah, next. Keep going.
Oh, this is all Paul's, I see.
Right, stop there.
Dear Professor.
There's a number like this. I got the idea from Gordon Thompson, who also teaches in Fife. He came up with a great idea. Kids also encourages literacy, and you allow them to be the professor. And what you make up is, it's like almost like a concept cartoon. You make up a wee scenario, and then they get the chance to advise. And this is just one of them. As I think there are 3 there, and kids can work in groups, and they come up with they actually quite like it. He tells me that my girls are a bit past it. The teenagers quite like reading these mags about, my wee brother makes a mess of my room. What should I do? And he uses them quite a lot in the classroom. So that's 3. The other one, and I hope you're all aware of concept cartoons, Brenda and Stuart Naylor. These are published by Millgate House. The next one shows one from the book, and then they're actually relatively easy to make up. Next one's very straightforward, and again, you can look at that in your own time. Stop that. That one there is one I've used with primary teachers. I would say roughly 30% of primary teachers in Scotland are able to get the correct answer to that one. Roughly 30%, which perhaps reflect the number that have a chemistry qualification. Yeah, and I've used that a lot. Next one, that's just one I made up. Folk will get a chance to look at that at their leisure. Corners is where there are materials, resources in different corners of the room. The class is divided into groups, and one member of the group goes to each corner, and they come back, and it's their job to teach the the rest of the class what's in their corner. Has to be structured very, very carefully. I could take you to classrooms where it would be chaos. I can take you to classrooms where it works like a dream. And the kids really like the responsibility of working together to come up with what they are going to be doing when they teach the rest of the group. Has to be very carefully managed. Okay. The Ring of Fire, I think, is the next. Oh, value line. That's where we have a number of issues. And well, you're looking at one at a time. You have an issue, they'll discuss the issue, and then they've got to make up their mind the extent to which they strongly agree or strongly disagree. And seldom is it an actual value line as such. Normally, it's just two bits of paper on the board. And what they do is they put it at close to one end. The sort of issues that they might be discussing. Next slide. Yeah, you could see them. Ring of Fire, where there is a question and an answer, and what they've got to do is go round the room in order to find the answer to the question. When they get to the answer, they find there is another question. And again, they're working in pairs normally, sometimes threes. They start off somewhere and it's their job to go round. I've seen it done in a whole class setting where each kid gets an answer and a question and the teacher really controls it from the front. You know, here's the question, who's got the answer? What's the next question? Here's the answer. Yeah, that's something else. Peer assessment. Classrooms where the kids actually involved in the assessment of others. If you're going to be doing that, then you certainly need very, very clear success criteria. And I was in a school where a kid would finish a graph, then someone else in the class would be told to go and get the success criteria, and they would check and actually mark the graph. How good is this graph? How good is this whatever? How good is this plan? The teacher had a range of these, and it was a delight to see the way they were used in the class. But you have to have very, very carefully written success criteria for the kids to be involved in the peer marking, peer assessment. And next one, Handley, this is really just a memory game. It's pity Paul's away because I know he's used it a few times. There is a drawing of something in the front, and the class is in a team, and all number ones go out to have a look at the drawing for maybe 1 minute, and then they have got to start drawing or tell the rest of the team what is in the actual picture as such. And then number 2 go out, and then number 3 go out. Yeah, sorry, I'm a bit rushed with that one. Learning outcomes. Okay. Yeah, okay, no, but we can move on. Okay. Anyway, yeah, learning outcomes for today. These are the learning outcomes. I've committed the cardinal sin that I haven't really left enough time. It's what Douglas is saying is what I sometimes hear in the class. By now you all will know what's meant by active learning. You will all know. That's not the way to do it. Certainly not the way to do it. And I apologise for the rush and trying to include just a little too much, but I hope you've all found it useful in some way or another. The last slide. Next one. Oh yeah, and this is a bandwagon. I got Trish Nichol when she was at Pennycook High to talk to the audience at St Andrews, where the chemistry teachers have a jamboree. They used to have a jamboree once a year, pre-COVID, and she finished it up by saying, this is not a bandwagon, try it and never regret it. And I have to say, if you looked at the results of the chemistry department in the school she was in, it would certainly convince you that there's something in it. Try it and never regret it. And I suppose it's a fairly good message to finish off with. There's a slide now from the RSC, I think. Yeah, Nicola, do you want to say anything about that one?
It's just talking. This is just talking about a report that the RSC have recently issued. It's talking about chemistry for all and asking the question, is chemistry actually accessible for all? It's been a 5-year study. They're going to take the learnings from that study and do another 5-year study to talk about making chemistry accessible. So, you know, that you can see that it's got a shortened URL there. So just have a look at that. And
Right.
I'll pass on back to you.
I was just going to finish off as well, just by reiterating what Paul said, just his last comment before he left. Think about where you use these techniques. You know, Paul is absolutely right. A lot of these techniques are not your first stop to go to, right? Pupils need the information or the knowledge before they can do a lot of these things. Don't think for a second that I don't think there's any place for standing at the front using some sort of direct interactive instruction and teaching your pupils things. You know, when I was teaching atomic theory, I'd teach them atomic theory. You know, I'm standing at the front with my whiteboard or a PowerPoint, and I'm teaching them atomic theory so that they've got that knowledge. I'd use questioning throughout that, you know, to keep it interactive. But then I'd be going on and using one of these sort of techniques just to embed that knowledge and get the pupils kind of thinking about that and linking it to other things. You know, but there's still a huge place for you as the teacher, you know, standing at the front using that direct instruction.
Yeah, I mean, I would completely endorse that. I can at one point, Douglas got the reputation of saying, you know, there's no place for direct teaching, you know, for teachers standing at the front. And I can sort of understand how that came about, but the phrase I tended to use is, you know, a measure of active learning is required, and I think it is a measure. They can't really get involved in many of these activities unless they have the knowledge base, and it's a very, very, thanks for making it, Colin, thanks to Paul. I think all that remains is for me to say thanks again to everyone for joining us today. Thanks to all those who have been involved in getting us from the start, even the registration, through to the end this afternoon. If you have any questions, if you have any comments, if we've upset anyone, we've got 2 email addresses, and don't worry about telling us that you disagree with this or that. We're quite used to it, and we'll try and reply as diplomatically as possible. But if you've got any comments in today's session, if you've got any comments relating to future sessions, because this is the first one of 3, we hope to have another 2 between now and Christmas. If any kind of comment that you think would be helpful, please let us know when you have the time. So the plan was actually to try and finish the more formal part in an hour, and we'd stay open till 5:30 for anyone that wishes to stay to say hello to folk that they haven't maybe seen for a wee while. And I think we're still going to stay open till 5:30, Nicola. Yeah?
Yes.
So if anyone wants to comment, to say anything or whatever, Nicola will try and manage this as best she can. We'll leave it to her if she's asked to deal with everyone speaking at the one time. Okay, but thanks again to everyone.
Douglas, is this those slides, the presentations are available in the email?
Nicola?
Yes, we will send out an email to all the attendees and the people who registered, and I'll include a link so that you can go and get the slides. We'll add the things that Paul mentioned, the Tarsias, we'll add that to it as well, and any other slides. We've also got an evaluation, which we would really appreciate your time doing. I think it's only got 3 questions on it. I'll quickly dig that out and I'll put it into the chat if people want to look at that, and that will really help us develop our offering for teachers here in Scotland. Oh, can't you? Still
no,
can't see it?
Chat.
Yeah, chat is not active.
No, it might be worth. Might have to email that out or something, because
yeah, I might need to hang
we
on.
really want your feedback on what you'd like to see in future sessions and anything like that. Or any feedback you can give us will really, really, really be appreciated about what you think you need.
I'm just trying to look at the chat in case I can show chat bubbles. I'm going to. Can people see it now?
No.
Okay,
Yeah.
well that's all right. I'll send it out in the one place, and I'll send the 2 links, and you can do it.
Is that the in the slides the Tarsia puzzles and every contents are there in the slides? Yeah.
Yes.
Okay, that's fine because I was so interested in the puzzle. Puzzle is really interesting. Yeah.
Have you used Tarsia before in your teaching?
No. This is the first time I have heard, to be honest.
They're useful. There'll be other people here who have used them. Is there anybody here who'd like to kind of share their experiences?
I think you should give a prize for the first one to speak now.
Someone's got their hand up. Is that Louisa Bird? Just got her hand up, yeah.
It is Louisa. Louisa, you put your hand up.
Hi guys.
Hi.
Yeah, just to say I've used quite a lot of these things. I think I probably went to when Douglas did this active learning the first time about 15, 16 years ago back in Edinburgh Uni. So
We're not that old, surely.
I'm fairly sure you did this about 15 years ago at Edinburgh Uni, but a lot of the stuff has developed and improved. Obviously, I want to know more about active learning. I'm probably going to email Colin about that specifically for chemistry retrieval practice. But Tarsia has worked great in class. A lot of the stuff Douglas was talking about, I've been using for a very long time. But it's just about, as Douglas said, it's about working out what works for your kids for that particular activity. And Tarsias are great as a revision task. Carousels are great as a revision task. And it's just keep mixing it up. Don't keep it the same all the time because they get bored.
I would always iterate as well. I mean, I like card sorts. I like Tarsia puzzles. But I also like a work-life balance, so do this in moderation, right? Card sorts take up a lot of time, okay? So don't be thinking of just doing everything with a card sort or Tarsia puzzle, or you'll find yourself up all night cutting out things and laminating things, right? And I'm all for teacher well-being. So yeah, card sort's great, but don't be thinking, oh, I'm going to make up hundreds of those. Look after yourself. You know, as Louisa was saying, as Paul was saying, think about what is it I want my pupils to learn. And is this the best way for them to learn? You know, card sorts might be great fun, but it might not be the best way for them to learn that particular concept. There might be a better way for them to learn that concept. So have a think about that before you kind of devote a couple of hours of your life to printing out things and cutting them out and laminating, etc.
Colin mentions laminating. I always used to say, you know, with all the folk who are now getting involved in active learning, if ever you're thinking about giving up the day job, selling laminators, I think must be a good business.
But I think the card slots, once you make them, and it's used for other years as well. So the same things, yeah.
It's only once you've laminated it you spot your mistakes.
Yes. That's why the laminator business is so good.
But for the, I have an experience that when learning about the periodic table, and I used to make like poetic versions of the sentences so that I can learn all the 113 elements at once by making a poem.
Yeah, mnemonics are good ways of learning things as well. They're really kind of good tools for some things, you know, for
yeah.
remembering your diatomic elements.
I still remember till the gold, the highly Vivoga or something like that, and making in a sequence so that you won't forget the atomic numbers, the weight, because it goes in the sequence, and so that you can easily figure out what the atomic number of which element is. Yeah.
I think they should pick in someone, Colin, and really, and if they don't want to speak, they can pass. What about Abby? Is Abby still online?
Is Abby? No, Abby's away.
She's away.
Abby's away.
Who we would pick on then?
Picking Susan. I want to speak to Susan.
Susan.
Hi, Susan Mailder.
Hello, Susan.
Hi there. Thanks, Colin.
How you doing, Susan?
I'm very good. As you know, I do love a card sort.
You do?
Yeah, and so I'm well into laminating, but I also found as well that I liked, and the students also liked, when I got stuff wrong on purpose. So one of my plenaries often used to be spot my mistake. So I would do something, project it up, and that would be it. They would, so not only would they have to remember the calculation, so they'd need to know the calculation, but then they'd have to spot my couple of other mistakes that I'd thrown in there as well. So I class that as active learning. I hope that you do too.
No, absolutely. I mean, that's like an incorrect answer. Absolutely. It just comes from a different source.
Yeah. And because I'd made it, they loved it even more.
Yeah.
More enjoyable, isn't it, for the young people? Yeah.
Who else do we want to speak to?
Okay, anyone.
Well, you do. You're the boy. You're in control.
Anyone want to share anything else that they have used in class that they think worked well? Everyone's being shy. They're probably thinking about their dinner now.
I'm
Shirley, did you just
Yes,
unmute
Shirley.
yourself there?
Yeah, I did. I think maybe coming from a different side, because although I'm a teacher, I'm teaching in the FE, so I'm teaching in a further education college, and it's still a lot of the same syllabus that we're doing.
Yeah.
But I quite like to pick up on misconceptions, because having been through the system before, then there's a lot of misconceptions. I've got girls at home that have been through the system as well, and it's amazing what you can pick up from that side and take it back into the classroom and explain in a different way or ask what their feelings are. So that's quite good.
Yeah. There's a great resource of diagnostic questions that you can use to kind of challenge misconceptions. I think it's in stem.org.uk. If you just Google like the kind of they're called, I think it's Best Evidence Science Teaching Best. If you just Google Best Diagnostic Questions, and they're great. They're just already on PowerPoint slides, and you also get a wee leaflet with it that explains, like, why. It's just basically multiple choice questions, but the 3 kind of distractors have been chosen really carefully as common misconceptions, and you can use them with pupils. Just get them to vote on what's the right answer, and really just similar to concept cartoons. Really, just digging out these misconceptions and being able to have that class discussion about why that's a misconception and why it might not be the right answer.
Mm-hmm.
Louisa's got her hand up again, or is it still up from before?
No, it went up again.
No, it's a new one.
Oh.
The one I was going to suggest is just a really simple true or false. I literally have a T and an F on either side of my room, and it's taken on board the kind of things that Douglas has said, but it makes a nice plenary if you've got a couple of minutes just to get them to vote with their arms, to say, like, give them a statement. It's back to that, sorry, my sister's just tried to call me and hijack my thing. Back to that kind of misconceptions at the end, as Shirley said, give them a statement. They can decide if that statement's true or false, then talk about why it's true or false. But really simple, and it doesn't require any laminating or any pre-prep. It's just a T and an F on the wall, and they vote with their hands, or vote with their hands, the T and the F.
Brilliant.
Sorry, my washing machine's on, so I'm not leaving the thing on.
Has anyone else got any questions?
Fran McDonald, is she still there?
She might talk to us in that automated voice again. I don't know.
She
could have told it. I'm sure Fran said she couldn't get her microphone working.
She's away walking the dog.
Oh, everybody's ready for their dinner.
Yeah.
Is that us then?
We'd really appreciate your feedback.
Yeah.
Of all kinds. Because we very much would like to build on today.
Yeah.
And we had a few teething difficulties, but we've got through to the end one way or another. And we're aware that there are things that we could do better, I'm quite sure. And I'm sure you can help us as for the next 2. We haven't really decided the next 2 as yet, but any suggestions?
Yeah, if you're thinking questioning techniques or calculations in chemistry like that, don't be scared just to get in touch with us and let us know what you would like to see.
And we also know of teachers who have given presentations of different kinds to staff in their own school or at meetings. And we hope, if not over the time between now and Christmas, we hope that in the fullness of time, we will have presenters who will present on what they're actually doing in the classroom. Real teachers talking to real teachers. And we know of a number who do that at the moment. So anyone who feel that they would like to make a contribution, even if it's a small contribution, we might manage to get a few small contributions and have a sort of 57 varieties, maybe not quite 57, but if you've got ideas and would like to contribute and give us an idea of what it is and the time it would take, then we would certainly try to build that in.
Absolutely.
I hesitate to say a safe journey home.
I know,
Have
a
a safe journey home.
If you're not home